Hello, Algebra 1.5 students. Today's lesson is on factoring trinomials that do not have a GCF that we can factor out or are not grouping. And so just to remind us about foiling, factoring is basically unfoiling or defoiling. And so just to remind us, the FOIL method, f for the first term, so I get x times x, get an x squared there. And then I do the x times the 3, so the last terms, that's a 3x. And then I do the 2 times the x, and I get a 2x. And I get a 2 times the 3, and I get a plus 6. These would be the two terms that we get on the diagonal if you use the box method. I call them the middle terms. They're the oi of the FOIL, the O and the I. And I'll refer to that as we go through these problems. So then I put them together and I get x squared plus 5x plus 6. So there's our answer when we multiply those two binomials together. So in today's work, I actually give you the answer, the trinomial, and say what were the two binomials that gave me that. Notice there's no common factor other than 1. There's not an x in all these, and there isn't a common number other than 1 in all of these. And so we're going to start out with the most basic kind, where they're both positives here, and it's an x squared. And so I'm just going to write two sets of parentheses, and it's really kind of, all right, I'm going to put x's in my first spots in both of those, because I know x times x will give me that x squared term. And then because this last thing is positive and it's multiplication, I know that both of the numbers had to be positive to give me that, or both of the numbers had to be negative to give me that positive 6. So no matter what, when this sign is positive here, the signs are the same. What are they the same of? You look at the middle term, the O and the I result. So that tells me there's both plus signs here. So I'm getting there. So now I have to ask myself, what times what would make 6 that would add to 5? And so if you're getting a little stuck, one hint I like to give students is just write the factors that give you 6. So the one that's easy to forget is 1 in that number. But 1 and 6 do not add to 5, so that's not going to work. Well, what else? What times what makes 6? And that would be 2 and 3. And 2 times 3 gives me the 6, but 2 plus 3 gives me the 5. Because they're both positive, I do not need to worry about order in this. So if you put the x plus 3 first and the x plus 2 second, same exact answer. So you just factored a trinomial. You get two binomials when you do that. So here's your final answer for when you're given the trinomial. So basically we're defoiling or unfoiling these things. So I've got several examples just to give you guys some more practice and some more looks here. So it's x squared plus 7x plus 10. So I'm going to write my two sets of parentheses, and I'm going to put an x and an x for my first ones here. And now I'm thinking, all right, it's a positive 10 and it's a positive 7x middle term. That tells me these are both positive. They're both going to be the same in order for this number times this number to give me a positive 10. I couldn't have one of each sign, or I would get a negative 10. So what times what makes 10 that adds up to be the 7? So 1 and 10 would be one pair of factors, but that makes an 11, so that doesn't work. And then 2 and 5, yeah, 2 times 5 makes 10, but 2 plus 5 makes the 7. And again, it doesn't matter which one goes in there first and which one goes in second. So the order of these is random, just whichever you like. So there you have it. You just factored a trinomial. All right, go ahead and try this one over on the right here. I'll give you a second. You can go ahead and pause, and then I'll work it out. All right, so two sets of parentheses, an x and an x here. And now I'm thinking, all right, plus sign at the end here, so it's positive 30. That tells me they're both the same sign. positive 11x for my middle term there, so I know they're both positive. And now what times what makes 30? Well, 1 times 30 makes 30, but that does not add to 11. Does 2 go into 30? Yeah, 15 times. Does 2 and 15 add up to 11? No. How about 3 and 10? That's getting closer, but no, that makes 13 when I add them up. And then 4, that doesn't go into 30. 5 goes in there 6 times. 5 and 6, they do add to 11. There's my winner. So, yay. And again, 6 first, 5 second, or vice versa, doesn't matter. Just so you have the two different binomials, x plus 6 and x plus 5. And then it's super easy to check. I'll just do that for you one time here. Go ahead and, if you like that box method, go ahead and use it. And see if you do get this original x squared plus 11x plus 30. X times x, that gives me the x squared. 5 times the x, that's a 5x. 6 times an x, that's the 6x. And 5 times the 6 gives me 30. And yep, my like terms, so I get x squared plus 11x plus 30. So real easy to check them. Just go and do your box method, or go ahead and FOIL if that's your preferred method. Alright, so really the only thing changing now for these next few examples is our signs. The basic idea is it's going to be 2 sets of parentheses. I know x is going to be the first term in both of these linear binomials. And now I'm thinking, alright, positive sign here, so that's still telling me both signs are the same. But now, because this middle term is negative 6, that means they're both negative. And now I'm thinking, what times what makes 9? Well, 1 and 9 do. I always start with that. Nope, that does not make 6. And then 2 doesn't go in there. It's not even, but 3 and 3, that makes 9 when I multiply it. And then 3 plus 3, that makes the 6. And because of these minus signs here, it's really negative 3 plus negative 3, giving me negative 6. Negative 3 times negative 3, that gives me the positive 9. So again, when the last term is positive, you know both signs are the same. When it's a negative middle term, that tells you both signs are negative. Alright, as you can see the second one over here, give that one a try. I'll give you a couple seconds. Go ahead and pause. Alright. So hopefully you started out with 2 sets of parentheses. X is in there. And now this sign is positive on my 20. My last term is positive. That tells me both signs are the same. And what are they the same of? They're the same as the middle sign. So these are both going to be x minus terms. And now 1 times 20, does that make a 9? No. How about 2 and 10? No, that makes 12. It's getting closer. 3 doesn't go in there. How about 4 and 5? Yep, those total up to 9. Multiplied, they give you the 20. And again, the order doesn't matter. So if you did the 5 first here and the 4 on the second one, same thing. So there you have it. You've just factored some trinomials without using GCF. You defoiled them or unfoiled them. Alright, still a couple of variations. Gets a little trickier now with negative last terms. So it's the same process. It's going to be a couple sets of parentheses, x and x for my first ones. And now because this last term is negative, that tells me that one is going to be a positive and one is going to be a negative. So if I'm multiplying two numbers together, if they're both the same sign, that makes it positive. When this is negative, that means there's one of each sign. And so now I'm looking to see what times what makes 14 that subtracts to 5. That's the difference. It's not what adds up to 5, it's the difference that will make 5. So again, 1 and 14, they're 13 apart. That's not going to make 5. And then 2 and 7, yeah, if you subtract 7 minus 2, that gives you 5. Now here it does matter where you put the number because they're not both the same signs. We have positive 5, so we're going to war with these. We need the 7 to be the positive one, so it wins that war. So it's plus 7 and minus 2. So if you look, you get 7 positive times negative 2. That gives you the negative 14. 7x for the inside minus 2x for the outside. Those sum to be the 5x. And you can do that box method if you want to double check. All right, try this one over here on the right and see how you do on that. I'll give you a second to pause here. All right. Couple of x's to start my linear binomials. And now it's minus on the last term here. That tells me there's one of each. And now what times what makes 15? Well, 1 and 15 do. That doesn't give us a difference of 2 though. 2 doesn't go in because it's not even. 3 times 5 makes a 15, and those are 2 apart. So if we do 5 minus 3, we get 2. Now we have to decide, where does that 5 go? Should it be a positive 5? No, it should be a negative 5 because your result of the subtraction gives you negative 2x's. So I need less positive. That'll be the 3x term for these inside ones, and negative 5x for the outside ones. Negative 5 plus a 3 going to war gives you a negative 2. So those are my final answers. I've got 2 more for extra practice. Kind of a weird result on this next one here, so we'll go through that one together. Whoops. So x squared minus 4x plus 4. So again, I'll have 2 sets of parentheses, x and x here. And now I'm looking at the last sign again. It's a positive 4. That tells me they're both the same. It's a negative 4x middle term, so that tells me they're both minus signs here. And now what times what makes 4? That goes to negative 4. So let's see here. I got 1 and 4, but that would add up to be 5. 2 and 2, those would add up to be 4. And it's negative 2 and negative 2. Now to be super cool, this would be okay. This is an okay answer. But to be super cool and to kind of finish it off, because they're both the same thing, we can actually take a shortcut. And it's preferred to write it like this. It's just a little less busy, looks a little cooler. This is a perfect square trinomial. In other words, if I square rooted this expression, I would get x minus 2. This is x minus 2 squared, giving me this perfect square trinomial. That's something you'll see in Algebra 2. All right, last one here. This would have been a sticker problem back in the day when we had sticker problems. So I'll give you guys some time to work that out. All right. So this one has x's for our linear terms, just like normal. And now this was a negative 80. So one should be positive, one should be negative. And now I got to find out what times what makes 80. That's just 2 apart. This is going to be the difference of those 2 factors. So 1 and 80, not even close. 2 and 40, no, that doesn't work. 3 doesn't go in there. 4 and 20, well, I'm getting closer, but that doesn't work. 5 goes into 80 16 times, that doesn't work. 6 doesn't go in there. 7 doesn't go in there. 8 and 10, yes, those are 2 apart. So now which one needs to be positive and which one needs to be negative? I look at this middle term. So when I go to war with these 2 factors here, then I want them to be positive 2. So the 10 has to be the positive one because there's a positive result when we put those 2 together, and negative 8. There you have it. All right. I've attached a 3-question homework assignment for you. Good luck, and we'll see you next week. Take care.